Right now, beneath a quiet stretch of Oregon forest, Three Sisters is breaking open. The ground is rising. It has been rising for years, and 213,000 people are trapped inside a volcanic death zone most of them have never even thought about. Here is what makes this different from every other volcano story you have ever heard. Scientists who monitor this mountain announced it was dying. The uplift had slowed. The papers were written. The threat was over. Then, in the summer of 2020, a satellite 430 miles overhead caught the ground doing something it was never supposed to do again. It started rising. 12 inches of fresh volcanic pressure, silently stacking up beneath a patch of land larger than the entire city of Portland. And here is what nobody is telling you. The danger has nothing to do with lava. It never did. So what is actually building beneath this mountain? How little warning will anyone get? And why does the town sitting closest to it have no way out? In 1997, something started moving beneath a patch of Oregon wilderness, and nobody knew. There were no earthquakes anyone felt, no steam venting from the summit, no warnings flickering on any government monitor. Just the ground, quietly pressing upward, 3 miles west of South Sisters Peak, deep in a wilderness with no roads, no witnesses. By the year 2000, the rate had hit 5 centimeters a year. That sounds small. Picture the speed of a fingernail growing, but spread silently across a circle of forest 12 miles wide. Scientists eventually ran the satellite data backward and found something that stopped them cold. 5 full centimeters of uplift had already accumulated in silence before anyone had even thought to look. The mountain had been moving for years before the first instrument registered anything at all. By October 2001, a field crew helicoptered a GPS receiver and a seismometer onto a jagged peak called the Husband, a 7,524-foot outcrop sitting just over a mile from the dead center of the bulge. For the first time, the mountain had ears. What those ears heard over the next 15 years was a long, slow deceleration. The rate dropped and dropped. By 2017, it had crashed to just half a centimeter a year. Scientists wrote their consensus paper. The bulge was winding down. The threat was fading. The story was finished. It wasn't finished. In the summer of 2020, a satellite passing 430 miles above Oregon caught the ground doing something the models said it was done doing. Rising. Again. Not slowly, 2.2 centimeters in just 14 months, stacking on top of decades of accumulated uplift. By early 2022, another half centimeter had quietly added on. As of 2026, the total sits at 30 centimeters. Nearly 12 inches of fresh ground rise, pressed up from below, across an area larger than the entire city of Portland. The volcano that every scientist said was winding down had simply been holding its breath, and now it's exhaling again. But what nobody told you is what is actually doing the pushing. Here is what most people assume. The bulge is under the volcano. The pressure is rising toward the summit. The danger is up there, on that glaciated peak where you can see it. Every instinct points that way. Every instinct is wrong. The deformation center sits 3 miles west of South Sisters Summit. It is buried in roadless wilderness, with no trails, no infrastructure, and no monitoring equipment close enough to tell the full story. The source of all that upward pressure is not near the surface. It is 6 to 7 kilometers underground, nearly 4.5 miles straight down, deeper than most people imagine when they think about a volcano waking up. Here is the mechanism in plain terms. Magma is squeezing upward through a fracture system from somewhere much deeper in the earth. It climbs until it hits a ceiling, a layer of dense rock at roughly 4 miles depth that it simply cannot push through. So it stops rising. It pools. It spreads sideways like water flooding the bottom of a sealed room. And as it expands, it presses the rock above it upward, slowly, relentlessly, the way a hand presses into a mattress from below. The surface above it rises. Every few years, when the system pulses with fresh material, the ground 150 miles south of Portland gets a little wider, a little taller, a little thinner overhead. Dr. John Major, the scientist in charge of the United States Geological Survey Cascades Volcano Observatory, has said on the record that this is not the kind of ground movement that you or I would stand outside and detect at all. It is invisible to the human eye. It only exists in satellite data and instrument readings, and the instrument closest to the deformation center is a seismometer bolted to the husband itself, a peak that is also rising toward the satellites it talks to. Every measurement has a margin of error built into the very ground it stands on. But here is what should unsettle you most. An eruption is not required for this mountain to kill people. Most people hear the word volcano and picture lava. Rivers of molten rock crawling down a mountainside, slow enough to outrun, dramatic enough to film. That is not the threat here. It never was. South Sister is a glaciated peak. 5 separate glaciers sit on its flanks, holding back enormous volumes of meltwater inside natural dams, built from nothing more than compacted rock, debris, and ice. These are moraine dams. They look permanent. They are not. 5 separate times in the last century, glacial moraine dams on this mountain have failed without a single warning sign. They sent walls of mud, boulders, and water exploding down the mountain's flanks at speeds that leave no time to think and no room for second chances. Collier Lake collapsed in the early 1940s. Diller Lake failed in 1970. A flash flood tore down the mountain on October 7, 1966. None of those events reached the town of Sisters sitting downstream. Scientists note that distinction carefully. None of them reached Sisters. The next one might. The technical word is lahar. It means a volcanic mud flow, a fast-moving slurry of debris and water that follows river valleys and creek channels with mechanical precision, gaining speed and mass as it travels. USGS lahar models for this specific mountain give the town of Sisters between 30 minutes and 1 hour of warning from the moment a glacial dam fails to the moment the front of the flow arrives inside city limits. Picture a Tuesday morning in downtown Sisters. A waitress is pouring coffee. She hears a sound she has never heard before, a low, grinding roar building from the direction of the mountain. She walks to the door. By the time she pushes it open and looks toward Wycus Creek, the front of the wave is already inside the city limits, not approaching, already there. 30 minutes is the optimistic scenario. That window assumes someone is watching the glacier when it fails. Right now, nobody is watching it around the clock, and a lahar is only the first layer of what this system can unleash on the people downstream. The hazard does not start in town. It starts on a hiking trail. The Pacific Crest Trail, one of the most beloved long-distance routes in America, runs directly across the South Sister Bulge. Hikers set up camp on that ground every summer. They photograph the wildflowers pushing up through volcanic soil above the deformation center, with no idea what is moving 4 miles beneath their feet. A phreatic explosion, which is a steam blast caused by groundwater making sudden contact with superheated rock, would happen exactly where those hikers stand. The explosion that tore through Yellowstone's Biscuit Basin in July 2024 left a crater 60 feet wide with no warning at all. No earthquake swarm, no elevated gas, just an explosion where visitors had been standing moments before. That is the first layer of exposure. The wilderness. The second layer is the town of Sisters, 3,500 residents on the bank of Wycus Creek, 30 minutes downstream of an unstable glacier. The creek runs directly off South Sister's north flank, and arrives in town in under 30 miles. Nothing between the mountain and Main Street meaningfully slows a lahar. The third layer is the city of Bend, 109,389 people, large enough for a regional airport, 2 major hospitals, and critical highway infrastructure. According to hazard models, Bend faces a realistic chance of receiving 1 to 2 inches of abrasive volcanic ash during a rock mesa-scale explosive phase. That ash is not like ash from a fireplace. It is microscopic volcanic glass. It kills small engine vehicles. It shorts out heating systems. It closes Roberts Field for weeks. The fourth layer is Deschutes County, 213,072 people inside the full regional hazard footprint, the fastest growing population in Oregon this decade. More people arriving every year, settling deeper into the shadow of something they have never been warned about. If that number just stopped you, every subscriber is automatically entered in our monthly branded hoodie giveaway. Details in the description, but the population at risk is only one part of what this system can take down. Zoom out, and the consequences reach beyond anything local. Dr. John Major is the scientist in charge of the United States Geological Survey Cascades Volcano Observatory. He is not an alarmist. He is not a headline chaser. He is the person whose job it is to watch this mountain and tell the truth about what the instruments are showing. And what he has said on the record is worth reading twice. He said this process has probably been going on for a long time. They just never had the technology to see it. Read that again. The deformation beneath South Sister is not new. The instruments that finally caught it only existed because the technology finally caught up. Which means the question is not whether the mountain has been doing this. The question is how long it was doing this before anyone was looking. South Sister is one of only 2 known active uplifts in the entire Cascade Range. It is one of 18 volcanoes the United States Geological Survey officially rates as very high, the highest threat category that exists in the National Volcano Hazard Ranking System. Not high, not elevated, very high threat. The 2017 consensus paper said the system was decelerating toward dormancy. That paper was written by serious scientists using the best data available at the time. It was not wrong to write it. But the ground restarted in 2020, the exact year the models projected the rate would reach 0. Not a year before, not a year after. The year the scientists had essentially called the endpoint. That is not a small coincidence to sit with. Major has also said there would be more signs before anything large happened. More earthquakes, faster uplift, gas emissions. The monitoring system would see it coming. He believes that. But in the same interview, he acknowledged they never had the instruments to see what was already happening for years underground. Both of those sentences are true. They just cannot both be reassuring at the same time. So which version of this story do the people living inside the hazard footprint get to rely on? And what does the mountain's own history say about what comes next? Nobody can tell you which version of this ends badly. That is not a failure of science. It is the honest state of what is known. There are 3 possible futures for the South Sister system, and they are not equally terrifying. They just all carry real consequences. The first, the uplift stalls again, the way it nearly did in 2017. The rate drops back towards 0, the instruments go quiet, and the scientific community writes a second consensus paper. Then, somewhere between 10 and 20 years from now, a satellite catches the ground inhaling again. The cycle repeats. The region grows faster than any evacuation plan can keep up with, and the window for preparation keeps shrinking with every new subdivision built inside the hazard footprint. The second, the fluid source at 6 kilometers depth turns out to be superheated water and gas, not magma. A hydrothermal system under pressure rather than a true magmatic intrusion. In that case, The most likely failure mode is a pH-rheatic steam blast, sudden, local, and lethal to whoever is standing directly above it. Not a city-scale event, a wilderness-scale one, the kind that leaves a crater where a campsite used to be. The third, the system keeps refilling. The magma body at depth keeps growing. The last time South Sister went through a full eruptive sequence, roughly 2,000 years ago, it left a 5-mile fissure of black volcanic glass across its southeast flank. That feature is called the Devil's Chain. That single eruptive episode produced 20 separate lava domes in one continuous sequence. The landscape still carries the scar. Dr. Major says there would be clear warning signs before anything of that scale. More earthquakes, accelerating uplift, gas emissions rising through the soil. The monitoring network would see it building. He also said the process had probably been running for a long time before the instruments existed to catch it. Right now, on a steel cabinet anchored to basalt on the peak called the Husband, a green light blinks once every 30 seconds. The ground is still rising. The instruments are still listening. And the volcano everyone said was finished is still breathing in. Here is what stays with you after the data settles. This is not a story about a volcano that is about to explode. It is a story about a system that has been quietly changing for decades, in a region that has been quietly filling with people, watched by instruments that only exist because the technology finally caught up with what the ground was already doing. And the gap between what is being monitored and what is actually moving underground is still wider than anyone is comfortable saying out loud. The town of Sisters is growing. Bend is growing. Deschutes County is the fastest growing region in Oregon this decade. People are building homes, starting businesses, raising children inside a hazard footprint drawn by scientists who are careful to say they do not know exactly what comes next. The Lahar warning window is 30 minutes on a good day, and the glacier that could generate that Lahar has no continuous human observer watching it through the night. That combination, a rising ground, a growing population, and a shrinking margin for error, is not a movie premise. It is the current operating condition of a real place where real people wake up every morning without knowing the word Lahar. Stories like this one exist because the gap between what scientists know and what the public understands is often the most dangerous gap of all. If this video reminded you that the unexpected does not always announce itself, our free disaster preparedness toolkit is linked in the description. It will not stop a Lahar. But preparation is the only variable in this equation that any individual can actually control. The green light on the Husband keeps blinking. The satellite keeps passing overhead. The instruments keep recording numbers that the 2017 consensus paper said were no longer supposed to be climbing. South Sister is not dormant. It is not erupting. It sits somewhere in between, in that uncharted territory where the science is honest enough to admit it cannot tell you which direction this goes or when. The ground is still rising. The question is simply what it is rising toward.